In this video, we'll be talking about having to multiply with polynomial pairs and having to find a value of x so we can find the area of the triangle. So given that we have this triangle right here, we have x plus 2 and then x plus 4. One of the main things about this question is to note that this is a right angle. So by the Pythagorean theorem, we can state that a squared plus b squared equals c squared. The legs are considered the a and the b, so the legs are x and x plus 2. So we'll be using the substitution property in order to continue with this problem. So a squared, I'll input that as x, and the b will be the x plus 2. And everything else will be rewritten, so this is to the second power, this is plus, and this is to the second power. And the c squared is actually considered as the hypotenuse of the triangle, so that c squared is x plus 4. So I'll put that here. And again, this is to the second power. Let's continue with the process. So x plus 2, that to the second power is the same thing as x plus 2 times by x plus 2. So we're essentially duplicating that x plus 2 twice. The x to the second power, that's just x to the second power. So we write everything else. X plus 4 to the second power does the same thing as x plus 4 plus x plus 4. At this step, we need to apply the FOIL property, so FOIL. So first, outside, inside, last. So we'll do that for these two binomial pairs. So x times x, which goes for the f, is x to the second power. Now for the O part, the outside, that's x times 2. That's 2x. The inside, 2 times by x again, so it's 2x. And then the outside, which is considered the last, so that's 2 times 2, which gives us 4. Okay, again, I'm denoting that in red, and I'm going to rewrite everything else, so x to the second power plus, and why don't we handle the foiling property now with x plus 4 times x plus 4. So the f, the first, so that's x times x, which gives us x to the second. The O, the outside, is the outside term, so x times by 4, which gives us plus 4x. The inside is the 4 times x, which gives us plus 4x. And the last, the 4 times 4, which gives us 16. Great, so we have the blue, the x squared, we have the red, this, and then we have the green. So at the next step, let us add like terms. So for the like terms, I see x squared, I see another x squared, so therefore I'm going to add both of those two, so that's 1 plus 1, which gives us 2x squared. And we have another pairs of like terms. 2x plus 2x gives us plus 4x. And then we have that lonely number 4, so we're going to put that just plus 4. This is all equal to, and then again, we'll be applying the add like term theorem for the right side. X squared on this side doesn't have any other like terms to combine, so I'll just put x squared. 4x and 4x gives us plus 8x. And then we have that 16 at the end, which doesn't have any other like terms, so that's plus 16. Great, up to this next step, I see, or something that you should be able to take into regards is that we have an x squared, we have an x, and then we have a constant. This is considered as a quadratic. So we need to somehow push everything to one side and set it equal to 0. So we're going to push x squared to the other side. Let's push that 8x to the other side as well. And let's push that 16 to the other side. So all of these cancel out, which gives us 2x squared minus x squared. That's just x squared. 4 minus 8 is negative 4x. 4 minus 16 is negative 12. The fact that we canceled out everything on the right side, now the right becomes 0. So we have this expression that we need to somehow factor. So the important question we must ask ourselves is, what are factors of negative 12 that adds to negative 4? So you need to start playing around with factors of negative 12. Factors are two numbers that multiply to this number. So why don't we start by putting negative 12 times 1. Negative 12 times 1 is negative 12. Negative 6 times 2 is also negative 12. We also have negative 4 times 3. And it seems like up to that point we'll be relabeling things if we were to do it the other way around. So we could say negative 3 and 4, but again, we already see that happening here. So it's not necessary to do that. Now, these are factors that multiply to negative 12, but we need both pairs to add to that middle number, negative 4. So let's see which one of these adds up to negative 4. Negative 12 and 1 gives us negative 11. That can't be it. Negative 6 plus 2 is negative 4. Hey, that's what we need. And let's just validate that the last one doesn't make sense. Negative 4 plus 3 is negative 1. So yes, that doesn't work. So our match is negative 6 and 2. So the factored part of this polynomial is x minus 6. And we see that happening with that minus 6 and then the 2 is equal to 0. Up to this point, we need to split the binomials and set those equal to 0. So it's x minus 6 equals 0. X plus 2 equals to 0. And it's just basic algebra from here. We add 6 to both sides. This is x is equal to 6. On the other one, x plus 2 equals to 0. Let's subtract 2 to both sides. And x is equal to negative 2. Even though we have two solutions, only one must match the final result. So if we apply that negative 2 in for the x's, it seems like it's not going to make sense because we'll be inquiring a negative distance and we can't have a negative distance. So this one is out of the system. Now, what about the 6? So if we replace the x as 6, now we need to substitute 6 in for x. 6 plus 2 is 8. So I'll put an 8 here. And for the hypotenuse, let's replace x as our 6. So 6 plus 4 is 10. So we have a 6, 8, 10 triangle. So I'll just put a little bit here. 6, 8, and 10. And we can validate that this is actually does satisfy to the Pythagorean Theorem. 6 to the second power is 36. 8 to the second power is 64. And 100 to the second power is 100. 36 plus 64 is 100, which is equivalent to 100. So yes, that checks out. But the final question does ask to find the area of the triangle. Do you recall that the area of the triangle is 1/2 base times height? So the height is 6, the base is 8. So area is equal to 1/2 6 times 8. 6 times 8 is 48, and half of 48 will be 24. So 24 will be the final answer to this whole question. So area is equal to 24, and labelings haven't been provided for us, so we can assume it's just units, square units. Okay, and there you have it. So we proved that the Pythagorean theorem works for the triangle, and then we have found out, given with the dimensions, we can solve for the area of the triangle.